Welcome friends, welcome back to our channel Crystal Learning. So today we will see the subject basic thermodynamics and quite a very interesting question a student asked me. So till yesterday I didn't know the concept about this entropy in this respect. A new angle came in this entropy, that how you can see the entropy change if it is given. So when I studied more about entropy, I got to know something more about entropy from the books. So that thing I want to discuss with you today, so that whatever you know about entropy, some delta increment is there in the understanding of entropy. Let's see the question. The question says, which one of the following is correct? Okay. The increase in entropy is obtained from given quantity of heat transfer at low temperature. Second, the change in entropy may be regarded as a measure of the rate of availability of heat for transformation into work. Third, the entropy represents the maximum amount of work obtainable per degree drop in temperature. And final is all of the above. So correct answer is all of the above. And the question was asked in Engineering Services Examination Mechanical 2008. So first, after reading this question, I got confused because one thing is said that entropy is transfer with heat. Work done cannot transfer entropy. This thing we know. Okay, entropy can transfer with heat, but work done cannot take with itself entropy. So after seeing here work, so I thought these are two wrong. This must be true. But when I read more deeper into the entropy concept, then I got to know that all three options are correct. Let's see how it is being correct. Okay. So the mathematical statement of second law is given by delta is equal to dq by t. We all know this. Okay. So from this relation, if we ask that how much entropy is changed by adding or subtracting heat depends on temperature. At what temperature you are transferring heat. So since temperature is T is in denominator, so it is inversely proportional. Therefore, when a given quantity of energy is transferred as heat, the change in entropy is large if the transfer occur at lower temperature. So this is self-explanatory. No need to explain this, but we will see the physical significance. What is the physical significance of this meaning? Inversely proportional. T will low, then ds will be large. Okay, and vice versa. So recall, what is temperature? Temperature is measure of molecular motion. Okay. So if a transfer of energy to the surrounding at a greater temperature will change the molecular motion by small percentage. Already at higher temperature molecular motion are large. So if you are transferring a certain amount of energy in that surrounding, so that change in molecular motion will be low. But vice versa, if you are transferring the same amount of energy at a lower temperature where the molecular motion are low, then the net change after transfer of energy will be high or large. Okay, so this is the point discussed here. So let's see from a physical example. Suppose that you have 50,000 of rupees to give away. So if you give that 50,000 of rupees to a millionaire who has already so much of money, so that doesn't change any condition of that millionaire. But if you give that 50,000 amount of money to a poor person or a poor college student, for them that is a significant amount and will receive with a considerable joy, that he will become happy. Same principle can be applied for energy transfer via flow of heat. Okay. For example, if suppose you are transferring 50 joule of energy to the surrounding, then impact depends greatly on the temperature. How? That if the temperature of the surrounding is very high, the atoms are there in rapid motion. We know if temperature is high, then the molecular motion will be very high. Then 50 joule of energy will not make a large percentage change. We are talking about large percentage change in this motion. On the other hand, if 50 joule of energy is transferred to the surrounding at low temperature, very low temperature, where atomic motion is low, the energy will cause a large percentage change in motion. So this statement is very important. The impact of transfer of a given quantity of energy as heat to or from the surrounding will be greater at lower temperature. Whenever you transfer this energy at a lower temperature, that will have a significant impact of energy transfer. So this line is very important. Note down this line. Okay, that impact of the transfer of a given quantity of energy will be more at a lower temperature. Okay, so this point is clear. Now we will see the availability of heat for transformation into work, because we are doing work with getting input as a heat. So what percentage of heat or what part of heat is available for converting it into work? Because complete conversion of Q is not possible into work. Okay, we know already this. So suppose a Carnot engine is placed in between that and having based on Carnot cycle, and we know that maximum possible efficiency is achieved in Carnot engine because it is reversible. So there the formula is given in terms of temperature, that is T higher minus T lower divided by T higher. We know this. And 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 also the efficiency is given in terms of output upon input, that is dW output and dQ by definition. You just equate these two, equation 2 and 3. We get dW equal to dQ T1 minus T2 upon T1. So we are imagining a Carnot engine and we are saying that T1 equal to T, some absolute temperature, higher temperature, and we are experiencing a temperature drop of 1 degree in passing through the engine, or a unit degree drop is there. Okay, so T1 minus T2 is 1. So this efficiency term will become efficiency equal to 1 upon T. So now we are comparing efficiency 4 equation and third equation. That becomes 1 upon T equal to dW upon del Q. So that is del W equal to dQ upon T, and dQ upon T we know as entropy change. This is the very important formula received or we got from applying this unit degree, temperature range of 1 degree, and that too in Carnot cycle, giving maximum. This work done will give the work maximum work. Why? Because we have uh, placed Carnot engine in between this. Okay, so maximum work output. So from this equation, it is seen that for a given temperature drop, the amount of work obtainable depends on a temperature at which operation takes place. So amount of work will depend on the temperature at which it is working. More work will obtain from a given quantity of heat at low temperature than higher one. Inversely proportional. So if we want more work, then it should be working at low temperature. Hence, availability of heat transformation into work depends on the temperature at which transformation takes place. Okay, so availability of the heat for transfer, what percentage of heat is transferred for transforming the heat into work will depend on at what temperature it is working. Okay, so let's see some sentences. Okay, so this equation 5 following points can be summarized. First point we summarize up to the up to the discussion, whatever discussion we had till now. That first point is increase in entropy is obtained from a given quantity of heat transfer at low temperature. We know maximum effect will be there at low temperature. Okay, so DS is defined by like this. So first point is true. Second, since Carnot cycle has maximum efficiency, we know Carnot cycle has maximum efficiency. So from equation 5 that we achieved by help of Carnot engine. So that importance of entropy, which represent entropy, entropy can also represent what? The maximum amount of work obtainable per degree in drop in temperature. So this change in entropy is also representing maximum amount of work in which condition? Per degree drop in temperature. Okay, this line is also true. Okay, so let's read the third sentence. That is, the function del Q by T is known as entropy change and may be regarded as a measure of rate of availability of heat for transformation into work. Okay, so it is del Q, means it is giving rate of availability of heat, that what part of total energy, that is heat, is available for transferring into work. Again read this, may be regarded as a measure of rate of availability of heat. Complete heat is not possible, but what rate of availability of heat for transformation into work. Okay, del Q is there, that will be considered as rate. Okay, of heat for transformation into work. So all these three sentences are true. Let's read some other things regarding this. So this equation 5, that is this one, can be also given in terms of Joule equivalent. Joule equivalent you can revise, that is W equal to J times Q. Okay, this is Joule equivalent. When you convert heat to work, equivalent amount of work, you multiply J. So from this we can write this equation as, and eta efficiency term is 1 by T from equation 4. In terms of Joule efficiency, efficiency can be written in eta equal to del W equal divided by J times del Q. And now we equate these two equation, it will become del W equal to J times del Q by T, or del W equal to J ds. Okay, that is entropy change. This is another form of that dW and entropy change relation. So let's read few points more. That is, we have already seen that W equal to Q T1 minus T2 upon T1. We will just multiply this Q with bracket term, that is T1 upon T1 will cancel 1 and it will become Q, and minus it will become Q upon T1 and T2 is outside. Okay. So here, if you want complete conversion of Q, then this term has to be 0. So this line we got to know from this equation. So this equation shows that Q can appear as work or free energy W equal to Q only when this Q1 upon T1 into T2 becomes 0. This can occur only when exhaust is at absolute 0, that is T2 equal to 0, because this is not possible. So, at all other exhaust temperature, a part of energy is unavailable. So, for all other temperature, we know this part of energy is unavailable. We can't get work from this part of energy, unavailable part. It will be lost. Okay. So, we got to know from this, it is unavailable part and is represented by exhaust temperature T2 multiplied by this factor, and this factor Q by T1 is known as entropy of the system. Now we see this W is work, that is also given by free energy, that what part of total energy is converted into work, that is known as free energy, that will become Q is total heat energy as heat enthalpy. In terms of enthalpy, when it is in constant pressure, we can give Q as change in enthalpy, that is H total energy as heat, and T is this temperature, absolute temperature. Okay, exhaust temperature. S is entropy change, Q upon T1 entropy change. So we got the formula work equal to free energy equal to H minus Ts, and in mechanical and chemical function this free energy is denoted by F. Okay, in the thermodynamic relations chapter you can see this F and G term. So F comes from here, H minus Ts. F is free energy or energy for work. What part of work we have got from this, that is energy for work, free energy, that is completely converted into work, part of energy. H is total energy of the system and S is entropy per degree. Okay, so from this we got these few relations. So these are the references. At the end, I would like to thank these authors who have written such a good content for explaining the concept above that was asked in the question. So you can read these references for a more better understanding. But whatever was necessary or for explaining the question, I have explained already. But if some student want to read much further in detail, then they can refer these references. So let's come back to the question. So here we see that first option is true. Okay, first option is true. Second is change of entropy regarded as a measure of rate of availability of heat for transformation into work. This also we know is true. The third, that is entropy represent the maximum amount of work obtainable per degree of time. So all the three statements are true. We have seen in the explanation. So correct option will be all of the above. I hope you enjoyed this lecture and some new concept you got in respect to entropy change. That entropy can be also seen as the amount of work, maximum amount of work, how obtainable in per degree in temperature, and other things got clear about entropy change. So this is, I want to tell that the more question you solve, the more knowledge you get. So it is always said that please try more and more questions, solve more and more questions for better understanding. That will help in different examinations also and in interview also. If suppose this point was asked to explain in interview, then definitely you can now explain this. Okay. So meet you next time with a new question and a new concept. Till then, have a nice day.